Welcome everybody once again. So today we are going to see few more problems on orifice meter and pitot tube. So the theory part we have already seen how to the derivation of determination of the discharge using orifice meter, and pitot tube is used to determine the velocity of a flow in a pipe. In the last class we saw a few problems on venturi meter. So similar orifice meter and venturi meter, the formula for the discharge is almost the same. For venturi meter it is A1 A2. For venturi meter Q is equal to A1 A2 by root of A1 square minus A2 square into root of 2GH into coefficient of discharge CD. Whereas for orifice meter Q is equal to CD into AO A1, where AO is the area of the orifice and A1 is the area of the pipe or the inlet, into square root of divided by square root of A1 square minus A2 square into root of 2GH. Okay, so that is the difference. Now we will move on to our problems. So we will see two problems on orifice meter and some 3 or 4 problems on pitot tube. Our first problem is an orifice meter with orifice diameter 10 centimeter is inserted in a pipe of 20 centimeter diameter. The pressure gauges fitted upstream and downstream of the orifice meter gives readings of 19.62 Newton per centimeter square and 9.81 Newton per centimeter square respectively. See, that means this 19.62 is our intensity of pressure at section 1 and 9.81 is the intensity of pressure at section 2. The coefficient of discharge for the meter is given as 0.6. So CD is 0.6. Find the discharge of water through the pipe. We are asked to find what is Q. So we know the formula Q, that is the discharge Q is equal to CD into AO A1 by square root of A1 square minus A2 square into root of 2GH. So what is AO? AO is the area of the orifice. A1 is the area of the pipe or at the inlet. This is A1 square minus AO square. Here also it is A1 minus AO. Okay. It is AO square. Now, what is H? H is the difference in pressure head. Difference in pressure head. So, since here the center line is the same for Z1 and Z2, it is H is just the difference between the pressure head. So, now we will find what is AO, area of the orifice. So, in order to find AO, it is given the diameter of the orifice is 10 centimeter. So, DO is 10 centimeter. So, from this, we get AO is equal to pi into DO square divided by 4. We get pi into 10 square divided by 4. We get 78.54 centimeter square. Similarly, now what is A1? A1 is the area of the pipe. It is given as 20 centimeter diameter. So D1 is equal to 20 centimeter, from which we get A1 is equal to pi D1 square by 4, pi into 20 square divided by 4, we get 314.16 centimeter square. Now, so we have obtained AO and A1, and CD is already given as 0.6. G, the value for G is 981 centimeter per second square. Now we need to find H. So what is H? H is the difference in pressure head. That is P1 by rho G minus P2 by rho G. So what is P1? P1 is given as 19.62 Newton per centimeter square. So 19.62 into 10 raised to 4 Newton per meter square minus P2 is given as 9.81. So 9.81 into 10 raised to 4 Newton per meter square. So converting centimeter to meter, centimeter square to meter square, we are taking it as 10 raised to 4. Then rho G, it is 1000 kilogram per meter cube and G is 9.81. So we get 10 meter of water. So that is equal to 1000 centimeter of water. See, you should be very careful while conversion, okay? While converting, you should be very careful. So it is 1000 centimeter of water. Now we can substitute in this formula Q. So we get our discharge Q is equal to CD is 0.6, AO is 78.54 multiplied by A1 is 314.16 divided by square root of A1 square, that is 314.16 square minus 78.54 square into square root of 2 into G. Here everything is taken in centimeter. So 981 multiplied by H is 1000 centimeter of water. See, now this is expressed in Newton per meter square. This is Newton per meter square. This 1000 is 1000 kilogram per meter cube. And this 9.81 is meter per second square. Okay. So we get our discharge Q is equal to 68,213.28 centimeter cube per second. So dividing by 1000 we get Q is equal to 68.21 liters per second. We will move on to our second problem. Our second problem is an orifice meter with orifice diameter 15 centimeter is inserted in a pipe of 30 centimeter diameter. The pressure difference, that means orifice diameter, that is DO is 15 centimeter, D1 is 30 centimeter. The pressure difference measured by a mercury oil differential manometer. So the manometer is consisting of mercury on the two sides of the orifice meter, giving a reading of 50 centimeter of mercury. That means this is X. X is equal to 50 centimeter of mercury. Find the rate of flow of oil of specific gravity 0.9 when the coefficient of discharge of the meter is 0.64. See, that means the pipe is carrying an oil of specific gravity 0.9. Okay, this pipe is carrying an oil of specific gravity 0.9. So an orifice meter. Okay, orifice meter is placed on the pipe. Now, the coefficient of discharge is given as 0.64. Okay, so how will we find it? We know, as usual, our formula is Q is equal to CD into AO A1 by square root of A1 square minus AO square into root of 2GH. So now CD is given as 0.64. We will find AO. So DO is given as 15 centimeter. From this our AO is equal to pi DO square by 4. So pi into 15 square divided by 4, we get 176.7 centimeter square. Similarly, our D1 diameter of the pipe is given as 30 centimeter. D1 is 30 centimeter. Therefore, our A1 is equal to pi into 30 square divided by 4. We get A1 is equal to 706.85 centimeter square. Now we need to find what is H. Okay, so H, for the previous problem, the pressure intensity was given. Here the manometer reading is given. So from the manometer reading, we will find H. So H is equal to, we know the formula, it is X into, see the specific gravity of oil, that is the flowing liquid, is 0.9. For mercury, the specific gravity is 13.6. So mercury, it is heavier liquid, right? So X into SH by specific gravity of oil minus 1. So we get H is equal to, X is given as 50 centimeter of mercury. So 50 into SH is 13.6 divided by SO is 0.9 minus 1. We get H is equal to 705.5 centimeter of oil, because the flowing liquid is oil. Now we will substitute all these values in our Q. So Q is equal to, CD is 0.64 multiplied by AO A1. AO is 176.7 multiplied by A1 is 706.85 divided by square root of A1 square, that is 706.85 square minus 176.7 square into square root of 2GH. G is 981 since it is taken as centimeter per second square. 8 GH is 705.5 centimeter of oil. Okay, so we get Q is equal to 137,414.25 centimeter cube per second. Dividing it by 1000, we get Q is equal to 137.414 liters per second. Now we will move on to the next problems. So two problems we saw about orifice meter. So next problem we are going to see about Pitot tubes. Next few problems is on the application of Pitot tubes. So you know Pitot tube is nothing but a 90-degree bent tube, right? In order to find the velocity. So, and we know velocity V is equal to CV into root of 2GH. So Pitot tube is a 90-degree bent tube, that is called Pitot tube. So the question is, a Pitot static tube placed in the center of a 30 centimeter pipeline has one orifice pointing upstream and the other perpendicular to it. The mean velocity in the pipe is 0.8 of the central velocity. See, this velocity is called central velocity. The velocity determined using CV into root of 2gh is called central velocity. Find the discharge through the pipe if the pressure difference between the two orifices is 6 centimeter of water. Take coefficient of Pitot tube, CV is equal to 0.98. Okay, now we know the central velocity. Central velocity V is equal to CV into root of 2gh. It is given mean velocity V. We will write it as V mean, right? Mean velocity is equal to 0.80 times the central velocity. Also, we are asked to find a discharge. So, discharge is equal to mean velocity into area of pipe. Now, we will determine the central velocity. So, that is equal to CV. CV is 0.98 into root of 2 into G. What is H? See, the pressure difference between the two orifices is 6 centimeter of water. So, G is equal to this 0.98, 2 into G, we will take it as meter. So, 9.81 into H is given as 6 centimeters of water. That means it is 0.06 meter of water. Or you can write this as in terms of centimeters, 981 into 6. See, we get velocity V, that is central velocity V is equal to 106.3 centimeter per second. That is equal to 1.063 meter per second. Now we will determine the mean velocity. Mean velocity is given as 0.80 times the central velocity. So 0.8 multiplied by 1.063, we get 0.8504 meter per second. So our discharge is equal to mean velocity into area of pipe. So 0.8504 into area of the pipe. So it is given the pipe diameter is 30 centimeter. So pi into, see this is in meter per second, right? So we will convert this centimeter to meter. 0.3 square divided by 4. So we get 0.06 meter cube per second. Or we will convert this to centimeter. We get 85.04 into pi into 30 square by 4. We get 0.06 into 10 raised to 6 centimeter cube per second. Okay. See, this is without conversion of meter. This is in centimeter and this is in meter. Now we will move on to our next problem. So our next problem is find the velocity of flow of an oil through a pipe when the difference of mercury level in the U-tube manometer connected to the two tappings of the Pitot tube is 10 centimeter. See, difference in mercury level, that is X is equal to 10 centimeter. Take coefficient of Pitot tube as 0.98, that means CV is equal to 0.98 and specific gravity of oil is 0.8. So oil is flowing through the pipe, right? So the flowing liquid is oil. SO is given as 0.8. You have a Pitot tube. Now X is given as 10 centimeter of mercury. So that is equal to 0.1 meter of mercury. So from this we can find H. What is H? We know X into SH by SO minus 1. So that is equal to X is 0.1. Specific gravity of mercury is 13.6. Specific gravity of oil is given as 0.8 minus 1. We get 1.6 meter of oil. Because the liquid flowing through the pipe is oil. Now, the velocity of flow. Velocity is equal to CV into root of 2GH. So CV is given as 0.98 into square root of 2 into 9.81 into 1.6. So we get 5.49 meter per second. Okay, you can also write it as 0.98 into square root of 2 into 981 into. Converting this to centimeter, we get 160. So you can get 549 centimeter per second. Okay, now the next problem. A pitot tube is inserted in a pipe of 30 centimeter diameter. So the pipe is 30 centimeter diameter. The static pressure in the pipe is 10 centimeter of mercury, that is vacuum. Static pressure head. And the stagnant pressure at the center of the pipe recorded by the pitot tube is 0.981 Newton per centimeter square. That means P1, see that static pressure, that is the static pressure head. P1 by rho g is 10 centimeter of mercury vacuum. That means minus 10. And the stagnation pressure at the center of the pipe recorded by the pitot tube is 0.981 Newton per centimeter square. That is our P2. Sorry. So the static pressure in the pipe is 10 centimeter of mercury. The stagnation pressure at the center of the pipe is okay, recorded by the pitot tube. So this is P2 and this will be P1. This P1 is stagnation pressure head and P2 is static pressure head. Okay, P1 is stagnation and P2 is static. So that means our H is equal to P1 by rho g minus P2 by rho g. P1, that is a stagnation pressure at the center of the pipe, is given as 0.981 Newton per centimeter square. That is 0.981 into, converting it into meter square. Converting the centimeter square to meter square, it is 10 raised to 4 divided by rho is 1000 into G is 9.81 minus P2 by rho G is static. the static pressure in the pipe is 10 centimeter of mercury vacuum. That means 10 centimeter of mercury is your pressure head, that is P by rho G. So P2 by rho G is minus 10 because it is vacuum, it is minus 10. So it is minus 10 centimeter of mercury. So if it is minus 10 centimeter of mercury, it is minus 0.1 meter of mercury. Now, see, I will repeat this problem once again. This will create some confusion. We will write these things separately. Okay. H is equal to P1 by rho G minus P2 by rho G. We will find P1 by rho G and P2 by rho G separately. So this is flow of water. So the flowing liquid is water. Now P1 by rho G is the stagnation pressure head. Okay, stagnation pressure head. So stagnation pressure head is equal to 0.981 into 10 to the power of 4 in order to convert centimeter square to meter square, divided by rho is 1000 into G is 9.81. We get this as 1 meter of water. Now P2 by rho G is the static pressure head. So the static pressure head in the pipe is given as 10 centimeter of mercury. 10 centimeter of mercury. If this is 10 centimeter of mercury, it is 10 divided by 100 meter of mercury. That is 0.1 meter of mercury. That is nothing but 0.1 into 13.6 meter of water. So that is equal to 1.36 meter of water. Okay. And here you can see it is 10 centimeter of mercury vacuum. So it is minus. The value is minus. It is minus. Now we will substitute it in H. So H is equal to P1 by rho G is 1 minus P2 by rho G is minus 1.36. So we get 2.36 meter of water. Now the velocity at the center V, that is central velocity, is equal to CV into root of 2GH. CV is given as 0.98. So 0.98 into root of 2 into G is taken as 9.81 and H is 2.36 meter of water. So we get the central velocity as 6.668 meter per second. Now it is given the mean velocity as 0.85 times the central velocity. So mean velocity is equal to 0.85 times the central velocity. So we get 0.85 into 6.668. We get it as 5.6678 meter per second. Now we can find the rate of flow of water as V mean into area of pipe. So we get 5.6678 into area of the pipe. The diameter of the pipe is given as 30 centimeter, right? 30 centimeter. So it is pi into 30 centimeter, converting it into meter, 0.3 square divided by 4. We get 0.4006 meter cube per second. That's all. Now the last problem is a Pitot static tube is used to measure the velocity of water in a pipe. So the flowing liquid is water. You have a Pitot tube. The stagnation pressure head is 6 meter. Right, as we saw in the last problem, the stagnation pressure head. So P1 is stagnation and the static pressure head, that is P2, will be static, is 5 meter. Calculate the velocity of flow assuming the coefficient of tube as 0.98. So H is equal to P1 by rho g minus P2 by rho g. So P1 by rho g is a stagnation pressure head, that is given as 5 meter. Sorry, stagnation pressure head is given as 6 meter. 6 meter minus the static pressure head is given as 5 meter. So totally it is 1 meter. So our velocity, we know velocity is equal to CV into root of 2GH. CV is given as 0.98 into root of 2 into 9.81 into H is 1. So we get 4.34 meter per second. That's all. So that's all for today. Thank you for listening. In the next class, we will see a few problems on Orifice. Thank you.